Hello everyone. Engineering statistics and linear algebra. Single random variable, multiple random variable concepts were discussed. Next, we do switch our concept to linear algebra. Here, we do discuss what you mean by a vector, what is vector addition, what is actor a multiplication, what is vector addition and vector multiplication. This is the today's discussion. All right. Vector, it has both a magnitude and the direction. This is a magnitude and this is the and direction. So by combining these two results a vector. For example, you might have heard many times like kmph, 60 kmph, 5 kmph, 45 kmph, kilometer per hour. If that is the only statement, then it is a scalar here. And we can call it as a magnitude. Km 5 kmph, it is a scalar, it has only magnitude, it is an example for a speed. Along with a scalar, if you say its direction, for example east, along east direction the vehicle is moving in 5 kilometer per hour, then a direction is also added along with its a magnitude, then it is called as a vector. Magnitude along with the direction, here it is an example for a velocity. Velocity is a vector, whereas a speed is a scalar. A direction along with a scalar, that gives a definition of a vector here. If the same vector is represented in xy plane vector started at the origin, that is called as a tail here. Here it is a magnitude and this is a direction. So vector definition, it has two quantity, magnitude and the direction. Always it starts at the origin and direction depends on the xy plane. So vector, it may be having two components, three components, n components. So it is possible to visualize two's complement very easily for a human being. Three components means a three axis x, y, z, somewhat okay for a people. If the coordinates are increased like 4, 5, 6 and so on, it is very difficult for people to visualize it. So linear algebra is the concept where n number of axes can be visualized. So a number of components can be drawn in a number of axes. Axes can be 1, 10, even 100 or even 1000. It is difficult to visualize, but it is easy to calculate all the things if you go along the uh, linear algebra concepts. Alright. Consider here a 2 and 1 enclosed in a square bracket. So it is a representation of a vector here. It is a vector having two components in xy plane. Only two axes are available here. These two indicates two units along x-axis. One indicates 1 units along y-axis. As a result, this is the vector here. It is a mathematical representation. It is a graphical representation, one another same. Both are one another same here. Alright, consider four different vectors. Our first vector is minus 2 and 3. Minus 2 units along x-axis, 3 along y-axis. We can observe here. As a result, this will be the vector here. Alright. The next vector 1 and 2. Along x-axis it is 1 unit. We can observe. Along x-axis it is 2 unit. Vector number 3. Along x-axis it is 2. Yes, it is there. Along y-axis it is minus 1. The direction is opposite to positive values. We can observe here. And the fourth vector is somewhat different compared to these three, where the y component is 0 here. Only the vector is along x-axis. It is in parallel with x-axis, and also it is collinear with the x-axis here. X-axis and this vector, they are collinear in nature. So the along x-axis it is 4 unit. So y component is 0, so that it is at the origin. So these are some different vectors. All are having only two components. All are having only two axes. So one more different vector here, minus 2 and 3. 2 minus 2 along x-axis, 3 along y-axis. So the next concept is how vectors does look if the axis is increased to 3. X, y, z. If the one more axis is added, then how vectors should be represented? That will be the next concept here. Or consider x-axis, y-axis, and along with this, the one more axis is added here. That is z. How vector does it look? Vector is looking here. Both it is having x-axis and y-axis, and it will be having both x component, y component, and z component. Let us see with an example here. So these three components enclosed in a square buckets represent a vector that is having three components here. And three components, they are represented in three axes, that is x, y, z. Along x-axis, 2 units. We can observe the green color line. It is along x-axis, 2 units from the origin, and 1 unit along y-axis. Consider this as a y-axis. So this red indicates a 1 unit from the origin, and 3 units along the z-axis. This is the z-axis. So this color is 3 units along the z-axis from the origin. As a result, this is the vector here. Alright, just we have visualized two-dimensional vectors and three-dimensional vectors. Two-dimensional vectors will be having two components. Three-dimensional vectors will be having three components in it. Alright, what do you mean by vector addition now? Consider a vector v and vector w. They are two-dimensional vectors having two components x and y. What will be the result if these two are added? So w vector should be moved and it should be touched to the head of the vector v, As a result, join a tail of vector v and a head of a vector w. This is a resultant vector that adds a vector v and vector w. That will be the a result here. That is the rule of n addition. So here the vector v and vector w are given. Move this vector w such that its tail should be in contact with a head. So while moving, we should maintain a parallelism for this vector w. Once it touches the head of the once it touches the head of the vector v, then write one more vector. It should start from the tail of the vector v and it should end at the head of the vector w. That is done here. So this vector is the result of v, addition result of vector v and vector w. Alright, consider two vectors here, 1 and 2. One unit along x-axis, so it is 0.5 and it is 1, and it's 1.5 and it is 2. Okay, it is 0 and it is 1, and 2 units along y-axis, it is 1 and it is 2. All right, and one more vector, 3 units along x-axis, 1, 2, 3, and minus 1 unit along y-axis. If these two are added, what will be the result? You can see 1 plus 3 is equals to 4. Then 2 minus 1 should be equals to 1. That should be the result here. Our resultant vector should have 4 units along x-axis, 1 units along y-axis. That we see here. So move that second vector. It should touch the head of the vector, and draw the one more vector starting from the tail of the first vector, and it should reach head of the second vector. As a result, we can observe here 3 plus 1 is 4, 2 minus 1 is 1. That is the added result of these two vectors here. This is called as a vector addition. Alright, next is vector multiplication. Consider vector v. So 3 units along x-axis, 1 unit along y-axis. Alright, what is 2 into v? What is 2 into v? Here it is 3 into 1. If you multiply here 2, what could be the result? 692. Can you observe here? Can you observe the same vector after multiplying to a scalar to the vector v? Have we got 1, 2, 3, 4, 5, 6? 6 units along x-axis, 2 units along y-axis. So the 2 is any real number. It is called as a scalar multiplication here to the vector v. It could also be 1 by third. 1 by third of the vector v. The scalar is here 1 by 3. Here the complete vector and its magnitude is reduced to its 30%. So because the scalar 1 by 3 is used here, 1 by 3 of that vector, and this scalar can also be a negative number. So this is vector v. To this vector v, minus 1.8 is multiplied, so that this is the result here. So we have discussed a vector addition and a vector multiplication. So these two concepts are very essential to understand upcoming concepts here. So this is a summary. Two vectors, they are added. One vector, a scalar is multiplied. All right. So one a good concept here. So here 1, 1, 2, 3, 4, 5, 5 into 4. 20 vectors are given here. All are two-dimensional vectors having two components. If they are drawn in two-dimensional plane, what will be the result? What will be the result? Can you observe? 2 into 2 along the x-axis and along y-axis there are 2 units. So along x-axis 1.29, along y-axis 2.21. If you draw all these vectors, all 20 vectors in the same xy plane, then this will be the result. It looks like this. All right, so we do see in the next video. So we will discuss what you mean by span, what you mean by linear combinations, what you mean by independent vectors and dependent vectors, and so on. So we see in the next video. So like, share, comment on the video, and don't forget to subscribe the channel. Thank you.